Good morning, dear students. How are you all? I welcome you to the class of biology. I'll be taking biology today. Nitin sir is on his way to a class already. So I'll be taking a class today. I hope that's not a problem. So please take out your biology notebooks. Yeah. Just write your notes somewhere. Okay. Yeah. Please settle down quickly. All right. Good morning, Tamenglong and Shillong students. Other centers, please also report your attendance. Okay, Itanagar you do not bring. Okay, it's perfectly fine. Take out a few pages, and don't worry if you haven't revised. I will give you a quick revision of whatever I have done in the last class also. Okay, so don't worry about that. Just mark your attendance and take out a few pages, and then you can staple it or stick it in your biology books. Okay, biology notebooks. Just take out a few pages. Okay, so I hope that's fine. All right, I'll give you a minute. Yeah, it will be better if you don't write it in the middle of the physics notes, or you can just write it in your rough copy, and maybe you can rewrite it when you go home, but that's a lot of hard work to do. Instead, you can take some pages and stick it using Fevicol or something. Okay, all right. So let's begin. We were in the last class. I had started taking morphology. So what does morphology mean? In morphology we mean what the plant externally looks like. I want to consider about the root, I want to consider about the stem, I want to consider about the leaf. So these things are those that we cover. Alright. So when we talk about these things, root is the positively geotropic, negatively phototropic part of the plant. And root has a lot of modifications as well. The root has modifications. We talk about those modifications. First of all, there are three types of root. There is taproot, there is fibrous root, then there is adventitious root. Taproot is that type of root which develops only from the radical, and then there is the fibrous root, and then there is the adventitious root. Fibrous root is that root which is the characteristic of monocots, and it develops from the adjoining areas, the adjoining cells of the radicle. Okay, so radicle is the part which gives rise to the taproot, and then we have about just a second. So, and after that we have the taproot is the modification of radicle. It's found in all dicots. You can literally note that there are no exceptions. Literally, if there are a few exceptions, I'll tell about them later. Then fibrous root is a characteristic feature of monocots. Like you have corn, wheat, rice, maize, all these plants which have parallel venation leaves. Okay, these are monocots, and these have fibrous root. So please remember, radicle develops in the monocots, but immediately after the radicle gets established in the soil, what happens is it degenerates quickly. Now when it degenerates, the adjoining area cells, these cells adjoining the radical, they form the fibrous root. This is an important difference. Please do not note that, please do not think that fibrous and adventitious are the same thing. Fibrous and adventitious have a lot of differences. Adventitious root will develop from the stem nodes. That is very important. It will develop from the stem nodes. Also, the thing is, in adventitious roots, it can develop from literally any part of the plant body. But radical adjoining area, that gives rise to fibrous root. And fibrous root and taproot, they only come once in the lifetime. If any other kind of root is developing later on, it will be adventitious root. Okay. So adventitious root develops from any part of the stem, but fibrous root has a specific point of origin. Radical has a specific point of origin, or taproot has a specific point of origin. That is very important. Okay, I hope you remember this. So moving on, taproot has a lot of modifications. We talk about storage modification, napiform, fusiform, conical. I told you about carrot, radish. Radish has fusiform, carrot has conical. Then we have napiform, that is in turnip. Then there are other modifications like adventitious root modification, Ipomia batata, sweet potato. Then we have other modifications for specific purpose. For breathing, that type of root is called pneumatophore. It is found in mangrove plants. Mangrove plants are found in permanently submerged, salty, marshy areas which have no area exposed to the air. It is always submerged underwater. So these plants have roots that have learned to take air by coming out from the water surface, and they will pump air inside. These are porous roots. They have a large surface area, and these roots will have a large number of air pores. Wherever there is a root, it will develop a pneumatophore because the plant cells do not have a circulatory system. So air cannot be circulated. So every part of the root, after short distance, it will develop pneumatophores. Then there are prop roots. Prop roots develop in the case of banyan tree. It has a huge expanse of branches, and these branches, they cannot bear their own weight. The plant has to spread over a large area. So what can it do? It can only do one thing. It can develop prop roots which establish themselves in the soil. So every 10 meters or 1 meter, there will be a prop root, and it will form a pillar-like structure. That is the stem and the root, and it will help the plant to survive over a large area. Okay, so it can be spread over kilometers. A single banyan tree can be spread over a huge area. Then there are other modifications. We talk about stilt roots. Stilt roots are present in sugarcane. If you have taken out a sugarcane or a maize plant from the farm, from the field, so when you take it out, you can see that there are a large number of roots which come out from the stem above the soil. So they have a supportive function because the plant is very heavy, and monocot root is fibrous root which is weak root. It cannot establish the plant firmly in the soil, so it needs support. So stilt root is a kind of support root. Okay, it prevents it from falling off. Then after that, we had studied about the basic difference between root and stem. The root has no internodes and no nodes and no buds. That is how you will distinguish between an unknown structure which bears nodes. It will be definitely a part of the stem. It can never be a part of the root. Okay. In root, you can note node, internode, and buds are absent. So that is why potato is a root or stem. How can you identify by looking at it? I can only see that there are some large number of buds, and buds are never found in the root. So I can say it is definitely a part of stem and not a root. Coming on to regions of the root, there is zone of maturation, there is zone of elongation, then there is zone of meristematic activity, root meristem, and then there is the root cap. We start from the root cap. Root cap prevents the root from friction against the soil particles. So it grows downwards, and the apical meristem is pushing downwards. If root cap is damaged also, it can be repaired by quiescent zone cells. Root cap cells do not undergo cell division as such, okay, and they only protect the apical meristem. Multiple root caps are found in which plant? Anybody remembers? Pandanus odorifer and Pandanus species. It has multiple root caps. Pandanus has a lot of species. Pandanus genus, generally it has a lot of root caps. Okay, multiple root caps. Root caps are absent in which group of plants? Do you remember? Just raise your hands if you remember. I told you root cap is absent in a group of plants. Just raise your hands if you remember. Floating hydrophytes. Those plants which are growing on the surface of water, they will not encounter any kind of soil friction. So they do not require root cap. So if they do not require root cap, so it means root cap is unnecessary, root cap is absent. Instead, they have root pockets which help in balancing the plant. Alright. Okay, this is all about root that we have to learn. Then stem has nodes, internodes. It helps the plant to bear the organs like leaf, flower, etc. Now stem has a lot of modifications. Stem has tuber, corm, bulbil, and then there are runner, stolen. I told you a lot of these things. I hope you remember all of them. I told you basic difference between runner, stolen, all of that. Then moving on to leaf. Leaf is the structure which is dorsoventrally flattened. Leaf has also a lot of modifications. It can be modified into spine, tendril, a lot of things. Okay. Then moving on to the next part we have is inflorescence. So today I'll be taking inflorescence. I told you inflorescence, it can be of two types. It can be either racemose, it can be cymose. So now we are beginning our class properly. Okay, so let's talk about inflorescence. Let's talk about inflorescence. Just a second. Okay. So when you talk about inflorescence, okay. So just a second, this is having some problems. All right, so all right. All right, so let's talk about inflorescence. Inflorescence is of two types. It can be either racemose or it can be cymose. It can be either racemose or it can be cymose. Now, what is a racemose inflorescence? Racemose inflorescence. What is a racemose inflorescence? It is a raceme or racemose inflorescence is having an indefinite growth axis. Indefinite growth of flowering axis. It has an indefinite growth of flowering axis. If it has an indefinite growth of flowering axis, that means that as the flowering axis moves upwards, it will continue to bear new young flowers. So the oldest flowers will be at the base, the youngest flowers will be at the top. This type of inflorescence is called racemose inflorescence. Okay, so let's talk about it. In racemose inflorescence, the flowering axis continues to grow upwards while bearing flowers. Continues to grow upwards while bearing flowers. Okay, so the oldest flowers, this means oldest flowers will be at the base of flowering axis. The oldest flowers will be at the base, while the youngest flowers will be at the top. While the youngest flowers will be at the top. Okay, this is called racemose inflorescence. Thinking of racemose inflorescence, can you quote any examples from your daily life where you have seen racemose inflorescence? Can you think of any examples? Look, it's a bit rainy in my area today. I could not go out. I was thinking of plucking some flowers for you all, just to show you some types of inflorescence. But most of them are in the bud stage, so it's not very easy. I'll look again for some flowers tomorrow in my area. If I can find them, I'll bring them to you just to see some things. Meanwhile, you can look for some flowers like in your area in northeast. Right now, teak plants are undergoing flowering. So their flowers are quite big, and you can see this some kinds of inflorescence habits. I'll discuss them with you. Okay. All right. So let's draw a diagram of how racemose inflorescence looks like. Racemose inflorescence, the flowering axis is like this. It grows vertically upwards. Suppose this is the first flower, then the second flower will be in like this in acropetal succession. This is the third flower. This is the fourth flower, fifth, sixth, so on. Fifth, sixth, and so on. Okay, so this is the racemose inflorescence. Simple raceme or racemose habit. Simple raceme. This is the first type of inflorescence. Types, please put the heading. Types of racemose inflorescence. Types of racemose inflorescence. Types of racemose inflorescence. So the types of racemose inflorescence is, first is simple raceme. Simple raceme is already what you have seen. It is the unbranched racemose inflorescence. It is the unbranched racemose inflorescence. Simple unbranched racemose inflorescence. There is no branching of flowering axis. It is simple unbranched racemose inflorescence of pedicellate flowers. Of pedicellate flowers. What does pedicellate mean? Please raise your hands if you remember. What is a pedicel? Do you remember? What is a pedicel? I told this to you in the last class if you have seen my lecture. Students, please do a quick revision sometimes. It's not possible to cover everything in the revision, but I'll do that for you again. Okay, so take a look here. This is the mother axis. This is the mother axis. Then there is a flower coming out here. Suppose this is a, let's take a flower like this is a China rose. So suppose this is China rose, what will happen? First of all, I'll draw it like this. suppose this is China rose, so this is a flower like this. So this part is called pedicel. This part is called pedicel. This is called pedicel. The flowering stalk, the flower is attached by a stalk, a part of stem to the main plant or the axis, and this stalk is called pedicel. Okay. If pedicel is present, then these flowers are called stalked flowers or pedicellate flowers, and if pedicel is absent, such flowers are called sessile flowers. Okay. So this is a simple raceme inflorescence. Okay, you can say pedicellate flowers are arranged in acropetal succession. Are arranged in acropetal succession. Acropetal succession means oldest part is on the back, youngest is on the top. Alright. This is simple raceme. Then we have to talk about spike inflorescence. Spike. Spike is a special type of inflorescence in which it is just like the racemose inflorescence, but the main thing is here no pedicel is present. If pedicel is not present, then you can say the flowers that are present here, they are sessile flowers. Sessile flowers. Okay, so you can say it is similar to simple raceme inflorescence, simple raceme inflorescence, but flowers are sessile. So 1, 2, 3, 4, all these flowers that are present here, they do not bear any stalk or pedicel. So that is how they will look like. A flower is directly attached to the flowering axis, directly attached. Okay, so it looks like it is sticking here, 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 here. So example is, first of all, example of simple raceme. Simple raceme example is mustard. Mustard flowers are a very good example of simple raceme inflorescence. Spike inflorescence, a very good example is Echeiranthus. Echeiranthus. Okay, Echeiranthus is a very good example of spike inflorescence. Do you remember that whenever you are playing football or cricket and your ball goes to the suppose a wilderness area, okay, and you are picking your ball up or you are searching for your ball and some seeds start sticking to your clothes. Everybody remembers if you are visiting a wilderness area, and have you noticed some small pointed seeds which start sticking to your skin? Maybe they irritate or force you to itch on your skin. Maybe they give you minor scratches also on your clothes or your jeans, shirt, etc. Have you seen them? Just raise your hands if you have. It's a very common plant. That plant is Echeiranthus. Yeah, exactly. So right now it's not in the flowering stage. It bears flowers also which are sessile, and then it bears seeds which are also sessile. And it is a very long, the flowering axis is about this much long. It's about a meter long. And on that meter long flowering axis, a lot of pointed small seeds are found. These are sticking to our clothes and everything. Okay. So that plant is Echeiranthus. So whenever you see seeds like this again, you must take a look at that plant. That plant is spike inflorescence, having spike inflorescence, and the name is Echeiranthus. I'll send you some images also. I'm preparing I have prepared a inflorescence slide, PowerPoint presentation for you all. You can take a look at it and let me know how you think about it. Okay, it has all the images of these plants. Okay, it will be a great help. Now, simple raceme is done, spike is done. There is a third type of inflorescence which is very common in your exams, very important for your exams. Spike is good, but the most commonly asked question is about spike of spikelets. Spike of spikelets. Spike of spikelets. So, let me draw a plant for you as an example, and let me see if you remember this or not. It's quite common to see this. A few months from now, it will be everywhere. Do you remember what can you guess what I am drawing here? I am drawing a wheat cob or a rice cob, rice ear actually, or a ear of wheat. Do you remember this particular shape when the plant is undergoing flowering? Everyone has seen a wheat ear bearing the seeds, wheat or maybe barley or rice. Have you seen this, right? Okay, raise your hands if you have. Raise your and don't raise your hands if you haven't. So everybody remembers this. If you do not remember this, just take out a 1 rupee coin, and on the back side you can see there are two wheat ears hanging from the back of it, just after the 1 rupee coin on the back side. So this is called spike of spikelet. Now what happens here, it is an example of spike, but here the spike is present in different fashion. Here it has undergone branching, and for branching I mean this was a spike axis, like a spike. I have already told you what spike is all about. Now please try to imagine that this is a flowering axis and it has undergone branching, 1, 2, 3, 4, multiple branches. Let's say 9, 10 branches, and each branch coming here, it has a small spike inflorescence coming out from each branch. So this will be a type of distinction from spike, but it is like a collection of many spike inflorescences, and this is called spike of spikelet. So this will be many seeds in a close group. Okay, so that's what wheat and rice are all about. I'll draw the flowering axis plan. This is the flowering axis plan of wheat, rice, maize, etc. This is the main flowering axis. This is the main flowering axis, and it bears many small spikes, or called collection of spike called spikelets. So this is the first spike, 1, 2. Second one, 1 and 2. Normally it bears 2 flowers only. Very short. Each spike is very short. So this is flowering axis which is branched, and this is a small spike inflorescence. This is a small spike inflorescence. Spike. This is another spike inflorescence. These are multiple spike inflorescences on a branched inflorescence axis. Okay? Please draw it. Okay. This flowering axis is also called rachilla. Rachilla. Okay. Rachis branches into rachilla. Okay. So, just a second. I'll draw one other thing here. One more thing here. This is a questions have been asked about, as I remember, about gloom, palea, and lemma. Lemma. This is your homework. This is your homework to find out about these three terms. These are asked in the examination. It is related to spike of spikelet. It is related to spike of spikelet. Just draw a diagram in which gloom, palea, lemma, all three have been marked. This is your homework. I can tell you what happens is, gloom is a bract. Bract is a protective structure. It is born on the base of the flowering axis or rachilla. So suppose this is the whole size of the wheat flowering axis or rachilla, and it will be a many small spikes. So at the base on this part, two glooms will be present here. Okay, two glooms will be present at the base here. As we move upwards, you will find palea and lemma. Okay, but it will take a bit time to explain. I just want you to find out. If you will not find out, it comes to me, I'll explain it. Okay, so please try to do it. All these three are important for your NEET exams. Okay, question has been asked, gloom is a modification of your options are palea, bract, stem, bud. So what is a modification of? Answer is bract. It's a bract modification. Alright. So if you just Google up the wheat inflorescence, you will find palea, lemma, and gloom, all three. Okay. I'll just draw gloom here. This is the gloom. This is the gloom. This is lower gloom. This is upper gloom. Okay. Rest of all you find out what is palea, what is lemma. Okay. And lodicule, maybe it can be asked, it cannot be asked. I am not so definite about it because it's very difficult to see a question asked on various bract and bracteole modifications. Okay. Now Fourth type of inflorescence. Look, there was a modification of a spike inflorescence. Now I am going to give you a modification of simple raceme modification, simple raceme branching. Simple raceme branching. It is called compound raceme. Compound raceme. It is also called panicle. It is also called panicle. Okay. Alright, so what about panicle? Look, I told you what simple raceme. Simple raceme was 1, 2, 3, 4, 5, 6 like this. Now raceme undergone some branching, spike undergone some branching, spike of spikelet. Now raceme can also undergo branching, the flowering axis can undergo branching also here. It is called compound raceme. So let's talk about it here. First flower, second flower. Spike had sessile flowers. Now here will be pedicellate flowers. 1, 2 and maybe 3 also. There may be a third flower also like this. 1, 2, 3 and 1, 2, 3. So these are bearing their own branches. Okay. Alright. So this is called compound raceme or panicle. So you can say here peduncle, branched and bears small racemes individually. Okay, so you can say and bears racemes in acropetal succession. Acropetal succession, I told you, acropetal means like a tree. Like a tree has branches coming out. Okay, so older branches are at the base, younger branches are at the top. So that is called acropetal succession. Leaves are always generally born in acropetal succession. So this is peduncle which bears branches of racemes in acropetal succession. Example is mango. Mango is an example of compound raceme or panicle. Very good example. Mango is a best example of compound raceme. So we have seen simple raceme, compound raceme. We have seen simple spike, we have seen compound spike or spike of spikelets. Okay, so please finish it quickly. Mango is Mangifera indica, botanical name. Next we have corymb inflorescence. Corymb inflorescence. Okay. Corymb inflorescence is a special type of inflorescence. Right now there are some flowers which is called Malti. There is a long vine of flowers It spreads over a huge area and it bears pink white flowers. Pink white flowers like this. I'll draw the diagram, maybe some of you remember it. There are 5 petals. Anybody has seen this flower? It's in the flowering stage. It's an example of corymb inflorescence. Malti. Raise your hands if you have seen it. No, nobody has seen it. Pink white flowers. It's in the flowering stages as we speak. This time is the flowering season of Malti. Okay, no worries if you haven't seen it. No problem. Let me describe to you what corymb inflorescence is like. In corymb, what happens is in corymb, all flowers are on the same level. All flowers are on the same level. All flowers are on the same level, like this. So let me draw this. First flower, flower number 1, flower number 2. Now this is flower number 3, flower number 4, number 5, number 6. Now you can see it is appearing flat from the top. It is appearing flat from the top. Okay, it is appearing flat from the top. So this type of inflorescence is called corymb inflorescence. You can say here, all flowers appear, it's a raceme inflorescence only, all flowers appear to be at the same level because the older flowers have longer pedicel, because the older flowers have longer pedicels, and younger flowers have short or shorter pedicels. Okay. Have you written it? I hope you have drawn it. Just tell me to scroll if you are missing something, okay? So, it is seen in Cassia fistula, it is seen in Ibis amara or candy tuft. There are very good examples of corymb inflorescence. So, whenever you see some flowers which have longer pedicels, all flowers appear to be at the same level from top. Okay, you are seeing these flowers and they appear to be at the same level from top. You can say it is a perfect example of corymb inflorescence. Okay. So, Malti is an example of this type of inflorescence. I'll bring you some flowers maybe in the next class. Okay, that is tomorrow only. Okay, let me see if I can get these flowers. It's in the flowering stage. The only thing is during transportation to this place, the flowers get spoiled in my bag. So I will try if they can be preserved in some way. These are very delicate flowers. Example, Ibis amara or candy tuft, and then the other example is Cassia. These are very good examples of corymb inflorescence. Okay, everybody has done this. Okay. Then there is example of simple umbel. Simple umbel inflorescence. Umbel inflorescence is like this. You will also see the difference, a huge difference between umbel inflorescence and corymb inflorescence when I write this point. Now let me draw it. Okay, so the flowers which are first undergoing flowering, this one and this one, 2 and 2 and 3 and 3, and this is the fourth flower to open up. Now if you see the top of this flower, it looks like an umbrella. It looks like an umbrella almost. Okay, so almost looks like an umbrella. Please draw it, then I'll explain something else also. Okay. Have you written it? Okay. So how many of you, let me ask you a question, how many of you have Samsung phones? How many of you have Samsung phones? Just raise your hands. There is a wallpaper on Samsung phones, it's quite common. I don't have a Samsung phone, I'm just asking from you. Okay, yeah. So there is a wallpaper on Samsung phones which it looks like an umbrella, a white colored seed. If you blow it, it will flow in all directions. Have you seen it? Yeah. Okay, so if you have a Samsung phone, you might see that wallpaper. It's quite common to see that. So it looks like an umbrella. You remember that shape? And it's also very easy. Like if you blow it by your mouth, it's very easy to blow those seeds away. All those seeds will be scattered quickly. That is a dandelion. That's a dandelion. And that's an example of umbel inflorescence. Okay. So I was thinking where of an example to give to you that where you will easily observe this. A very good example is dandelion flowers. That wallpaper is of dandelion flowers and dandelion seeds. Okay. So after the flower becomes fruit and has some seeds in it, so it has some parachute mechanism of blowing it away. It forms an umbrella shaped structure. Okay. So it's called blowing dandelion. So this is an example of umbel inflorescence. Example, onion, and the other example is dandelion. You can also write Samsung wallpaper in the brackets. Okay, onion and dandelion. Okay. Now there are two other inflorescences. Just like there is umbel, there is compound umbel, and just like there is corymb, there is compound corymb. So we have to study his examples. Compound corymb. compound corymb. I can give you the pictures of all these inflorescences in some PPTs. So they look very beautiful. If you see these flowers and their inflorescence and their fruits, it's quite a beautiful thing to see. I'll give you that. Okay, I'll share this on the NEET droppers group. That PPT I'm talking about. Okay. So compound corymb is like this. It bears multiple flowers, and all those flowers are on the same level. This is an example of compound corymb. Okay. Example, just write the example. Pyrus malus, pear family. Okay, compound corymb. Then there is compound umbel. And there is compound umbel. Compound umbel means the flowering axis has undergone branching, and those branches bears compound. Those branches bear, each branch bears umbel inflorescence. Now similarly in umbel, the branching will be in the flowering axis, and it will bear, each branch will bear like this, and they will bear a collection of umbel inflorescence. It will bear a collection of umbel inflorescence. Okay, so this is a branched umbel kind of inflorescence. Example, just write the example. Example is coriander. Now very important thing, coriander name is Coriandrum sativum. Coriandrum sativum. There is a name of a whole family, and whole family has been named after this umbel inflorescence. Okay, so compound umbel and umbel are characteristic feature of family Umbelliferae, because all those plants belonging to this family have this kind of inflorescence only. Okay, umbel and compound umbel are characteristic feature. Umbel and compound umbel are characteristic feature of family Umbelliferae. Characteristic feature of family Umbelliferae. Okay, family Umbelliferae. All right. Then there is a very advanced kind of inflorescence. It is called capitulum or racemose head. Capitulum or racemose head, this inflorescence. How many people know which family this inflorescence belongs to? It is a characteristic feature of a particular family. Anybody remembers? Capitulum or head? It's the most advanced kind of inflorescence. It's considered an advanced kind of inflorescence. It's a characteristic feature of family. Nobody? Okay, it's a characteristic feature of sunflower family. Asteraceae. Please remember it. It's an advanced, it's considered an advanced type of inflorescence. An advanced type of inflorescence. Okay. So sunflowers are flowering at this time now. Everybody has seen sunflowers. Maybe you have them around you. Okay. So sunflowers, when you see the sunflower, you can see that there is an green colored structure at the bottom. It's actually called, the name has been asked in the examinations, it's called an involucre of bracts. Involucre of bracts, and let's talk about it later. So here there is a fleshy receptacle here. Cannot draw it by this color, yeah, maybe this. Okay, so I'm shading this. This means I'm referring to the receptacle or head. In this case, what has happened? The flowering axis has undergone a flattening. Right now the flowering axis was vertical. Now right now in capitulum what happens is the flowering axis has gone horizontal. It's not vertical anymore, it's undergone horizontal flattening. And here younger flowers will be at the center, okay, and older flowers will be at the periphery. In racemose inflorescence also, when you see from the top, okay, suppose this is racemose inflorescence and I am seeing it from the top. And when I see it from the top, I can see younger flowers are at the middle, older flowers are at the periphery, the outer circumference. In sunflower, the flowering axis has undergone shortening, and here also the younger flowers, it's a collection of flowers. One more important thing. This racemose inflorescence, capitulum or head, it's a collection of inflorescence. Okay. So in movies, we have seen this game of what's that game called? It's called He Loves Me or She Loves Me or She Loves Me Not. So they take a large flower and they pluck petals out of it, and the last petal, if it is he or she loves me, then she loves me, and if she does not, then let's forget it. Okay, so yeah, so there is a game like that. I have heard about it. I haven't played it. I'm not interested in that. It seems too funny to me. Maybe because I don't have a girlfriend. Okay, anyway. So the thing is, everybody has dismantled a sunflower or a tagetes, I mean a marigold flower. You have dissected or broken down such a flower, yes or no? Have you broken a sunflower, taken out the individual portions of that, yes or no? Or have you ever broken or dissected a marigold flower at least? Just raise your hands if you have. Come on. Nobody has even tried to break a sunflower. Okay. If you see a sunflower, take out, don't get punished for it. And I want you to look at what you can see inside that flower. Okay. Or you take a marigold flower, It's very easily available in the temples and so many things. So maybe you have not experimented with it. You can see there are black colored seeds inside that. Sunflower, marigold, cosmos, so many plants of sunflower family, even dahlia. If you look inside that, you will see black colored seeds. It is a collection of many flowers, and these flowers are called florets. And this game that people play, I haven't played this game honestly. So they take out the individual flowers from that collection of racemose inflorescence. So let me draw that here. There is a collection of flowers here. There are black colored seeds and they are attached. Okay, there is a problem here. Wait a second. Okay. Okay. Okay, so just a second, please wait. I'll explain in the meantime. The thing is, in case of sunflower, what you see outside the center and everywhere near the periphery, these are individual florets called individual flowers called ray florets. These are called individual florets called ray florets. Okay, so each is representing a flower. So let me draw the diagram again. The thing is, yeah, almost there. Inflorescence. Okay, okay, so there's a bit of small issue, just a second. Yeah, okay, so here this thing here represents an individual flower. This unit, it's actually a unit called a flower. This is a ray floret. I hope it is visible now. Okay, this is a ray floret. Ray floret. Okay, and then on each unit inside here, it represents a flower. Okay, these flowers are arranged like this here. Like this here. Okay, and the central disc florets are called disc florets. They are younger flowers, and the outer ones they are the ray florets. they are the ray florets. So let me draw this again. Okay, so it's visible now. This is called the capitulum or head. So it will be very clear to you once you take a sunflower and try to break that flower. If you take a sunflower and try to break that flower, you can very easily see it, what I am talking about here. Now these are this coiled portion that I am drawing here, it represents the stigma. So each flower has a separate stigma, and you can see the stigma also by naked eye. Nothing else is needed. You can see this stigma just by the naked eye. You will understand it once you take a flower. Don't get punished for it. Okay, please don't blame me afterwards that sir had told us to pluck a flower and we got punished. Okay, all right. So these are the ray florets and the disc florets. These are the disc florets. In sunflower, there is a central black colored or brown colored disc, and these discs are made up of individual disc florets. The outer ones are the ray florets. You can see these are the disc florets. This is the ray floret. Each floret is a separate flower in itself. This is the involucre. This is called, green structure is called the involucre of bracts. This is the longitudinal section of sunflower. Longitudinal section of sunflower. Or head. Okay. You can say capitulum or head inflorescence capitulum or head inflorescence is a characteristic feature of sunflower family. Sunflower family. Example, sunflower, the botanical name of sunflower is Helianthus annuus. Helianthus annuus. And there is another flower called zinnia. Many examples. Marigold is Tagetes erectus. Tagetes. This is also capitulum. Marigold. It's the botanical name of marigold. Okay, so these are all the inflorescences of types of inflorescences of racemose that we have to study. So that is the end of racemose inflorescence. Okay. So next we have to do types of cymose inflorescence and what does cymose inflorescence mean. Okay. Types of cymose inflorescence and what does cymose inflorescence mean actually. Okay, hope you are ready for that. Okay, so let me complete it. Let's put the heading cymose inflorescence. Cymose inflorescence. Everybody is maybe cursing me for interrupting their physics class. Okay. All right. So you had you had your plans of physics class, but it's perfectly fine if you get a substitution sometimes. All right. For understanding cymose inflorescence, take a look at those flowers which are present around you. Take a look at hibiscus, take a look at rose, then take a look at some other flowers like we have some orchids, we have datura, okay, and these flowers are very common and present all around us, okay, and these flowers represent the cymose inflorescence. If you see any plant from the distance, and you can see that there are a large number of flowers in a small area, it's a high probability that you are seeing some type of cymose inflorescence. Okay, it's a high probability that you are watching a cymose inflorescence. Cymose inflorescence is also quite common. Okay, so let's talk about it now. Cymose inflorescence. In this type of inflorescence, the growth of flowering axis is definite. The growth of flowering axis is definite. Okay. So if the growth of flowering axis is definite, what do we mean by definite growth? That means that the oldest flower is going to be at the top, and now if a new flower has to come out, it has to come out from the sides. It will not come out from the top. So the flowering axis has stopped here after the growth of largest flower or oldest flower. Now the new flowers will have to come out from the side of this oldest flower. It will have to come out from this side. Okay, there is no other way. It will have to come out from the side. This type of inflorescence in which the growth of a fluorescence axis or flowering axis is very definite, it is limited, it is called cymose type of inflorescence. Flowers are born in basipetal order. Basipetal order. This is the basipetal order. Oldest flowers are at the top, and younger flowers at base. Okay, youngest flowers at the base. All right. Now let's talk about types of cymose inflorescence. Please put the heading types of cymose inflorescence. Types of cymose inflorescence. Now types of cymose inflorescence, you can say it's of many types such as It is of many types such as monochasial cyme, monochasial cyme. Monochasial cyme or simple cymose you can say when peduncle bears a single terminal flower, when peduncle bears a single terminal flower and a single lateral branch, and a single lateral branch which also bears single terminal flower. Now it's looking very odd in language. I assure you it's very easy to understand. I'll just tell you. Bear single terminal flower. It's quite easy. Just see this diagram. It's like this. It's like this. This is the single terminal flower, first flower, oldest flower. After this, the next flower will come out like this. Second and second flower. Now the third flower will be here. Now first flower is terminal, second branch which is also resulting in terminal flower. Number 2 is terminal flower. Now number 3, this is also terminal flower. Now if new flower has to come out, it will come out from the side of third flower. So this is example of simple monochasial cyme. This is example of simple monochasial cyme. Now monochasial cyme is of also many types. It is of 3 types actually, but I will teach you only 2 here. It is of many types. The most easy ones to understand, which are given in your NCERT also. First is called helicoid cyme. Helicoid cyme or Bostrix. Helicoid cyme or Bostrix. You can see here it's a monochasial cyme. It is a monochasial cyme in which successive lateral branches develop only on one side, only towards one side. Now I see this, it's a very beautiful example. Like it looks very beautiful when you see in personal. This is how it looks like. I find it quite fascinating to watch this. It's one of my favorite flower patterns. First flower, second flower, third flower, fourth flower, fifth, sixth, seventh, eighth, Can you see how this is looking like? It's very beautiful pattern, like it's a coiling of a snail shell or a mollusk shell. It's following a beautiful pattern, a spiral pattern like this. It's really a beautiful example. It's coiling inwards. Okay, it's following a spiral pattern, and the flowers look very beautiful. Example is Hamelia, Juncus, etc. Okay, this is example of monochasial cyme. Second example is a bit typical, but it's not difficult to understand. It is called scorpioid, like a scorpion. Scorpioid or cincinus. How many people of you have seen a scorpion walking on the floor? Just raise your hands. How many people have you seen a scorpion walking on the floor? How does it walk? Does it walk in a straight line? Okay, you have seen, yeah. In the wild areas, there are a lot of scorpions there, and scorpions rush towards the warm places. They can hide in our shoes, they can hide in our, just you put the t-shirt away and you find a scorpion after some time if you are not too careful. So scorpions, when they walk, they take a step like this, they take a step like this. Okay, it's a alternate pattern. It's always, it's a bit towards this side and a bit towards this side. This is also what this inflorescence looks like. This inflorescence is like this. I'll explain. First flower, second flower, third flower is now not towards this side, it is towards the opposite side. Third flower, then there is the fourth flower, then there is the fifth flower. I'll draw it in the next page. It's a bit congested here. Okay, Scorpioid or cincinus. Okay. First flower is here. Second flower is here. Third flower is here. This is the fourth flower, fifth flower, and then there will be the sixth flower on the branch of the fifth flower. Okay. So this is what is meant by scorpioid. When successive lateral branches just a second, wait a second. Okay. When successive lateral branches develop on both sides of main axis in alternate manner. Example, heliotropium. Heliotropium. Okay. So I'll give you the picture. Like, I cannot show you heliotropium. It grows in the jungles of Mizoram, in the Bay of Bengal area, and it's found in the eastern portion of India. Heliotropium flowers. They have slightly medicinal properties, but most of them are preferred for their ornamental value. So heliotropium you can find in some nurseries, some gardens and some places. Okay. So at these places you can easily see that there are some very good examples of these flowers. Okay. So heliotropium I'll show you, yellow flowers, purple flowers, and it's not like the helicoid cyme. It's very beautiful thing to watch. Okay. So I'll show you these pictures when I send you the PowerPoint presentation. Okay. So I'll post it in the group today. Okay. All right. So Scorpioides cincinus. So what is happening here? First flower, second flower, third flower is not going towards the right side only. It's now towards the left side, then the right. Just like how a scorpion is walking. So some scientists must have seen that this looks like the manner of a scorpion, right leg, left leg, right leg, left leg. So that's how he compared it, that this is like the way people with the scorpion sun signs behave. Okay. Scorpio sun sign. How many people are having Scorpio sun sign based on date of births? How many people are having Scorpio sun signs? Okay. Alright. So Scorpios are said to be they have two sides of the same coin, and they know how to put the things together, and they are very well coordinated, but they have tendency to lean towards one side, then quickly towards the other side. So they can be very good diplomats. I hope, I'm not sure, but maybe you are a diplomat if you are a Scorpio. Just some fun things to share with you. Okay. Alright, so let's move on. Dichasial. Now monochasial cyme has been finished. Okay. Now we are going to cover dichasial cyme. Dichasial cyme means now there are going to be two branches. Monochasial cyme was a single branch, no branching there. Now there will be two branches here. This will be the oldest flower, one branch here, one branch here. Each branch will have its separate cymose pattern. Each branch will have its own separate cymose pattern. Okay, so let me show this to you. Dichasial or it is also called biparous cyme. Biparous cyme. Dichasial or biparous cyme. Dichasial or biparous cyme. This is the oldest flower. Okay, maybe I should use a different color for the flower. This is the oldest flower, number one. Now after this, there will be two branches here. One branch here and at the same point other branch here. Now there will be, this will be the second flower. These are both growing at the same time, so I cannot say which one is older. So they are both of the same age. Second. Okay. Now it will have this kind of pattern. Okay. So here, first, second, third, and third. Alright. I hope it's visible to you on the screen. It doesn't appear as black and white. Yeah. So I choose a good color contrast here, but I hope it's visible to all of you. Okay. So this is how this is happening here. Okay. This is how it's happening in this case. Alright. Everybody is interested in it? Okay. So this is the biparous cyme or dichasial cyme. I'll show you some examples of this. Biparous or dichasial cyme. Parous, a second. Diagrammatic representation of biparous or dichasial cyme. Okay. Example is just a second here. Yeah, okay. Example is jasmine. Jasmine, everybody remembers? Jasmine, everybody remembers? What is jasmine? I'm not talking about Jasmine from Aladdin movie, not her. Jasmine is a flower. Everybody must be remembering it. It has white, sweet, scented flowers. And these flowers are have the habit of opening at the night because it is an insect pollinated flower, and it's because insects which come at the night, it is pollinated by those insects, so it has a very sweet scent. Okay, so jasmine has a biparous dichasial cyme habit. Another very good example is teak, Tectona grandis, teak plant. Now this is also the flowering season of teak flowers. Okay, so I have some teak flowers, teak plants, teak trees actually growing near my place. So I think I can bring some teak inflorescence if I am able to climb on the top of that. Okay, I won't have to climb technically. I will have to climb on the wall and pick some flowers. So I'll show you this if I can do that. If the flowers have not fallen today, I'll show you them by tomorrow. Okay. So teak is an example of biparous or dichasial cyme. So the oldest flower is here, then there is a branching, second flower, then third flower here. Okay. So it has two branches growing like this. Okay. It is also called true cyme, but that is not required. Third very good example is not an example of biparous cyme. third type is multiparous or polychasial cyme. This I can definitely show you tomorrow, because this plant is also, the example of multiparous cyme is also in the flowering stage at present. It is called Calotropis or Madar. Okay. So look, botany becomes interesting only when you have a lot of examples to see. Otherwise it becomes boring when you do not have examples to see and things to compare to. Okay. Alright. Suddenly it has become so dark. Is it going to rain in your area? I can see the cameras gone dark. Is it gonna rain in your area, Shillong students? Suddenly it's become quite dark. Alright. Okay. Multiparous or polychasial cyme, you can guess how it is going to happen. I'll draw the diagram. Oldest flower is here. This is the oldest flower. Then we have first, second, third, fourth branches like this. Now we have cymose branches here like this. It's complicated to draw it already. You can understand what I'm trying to do here. Oldest flower, second oldest flower, younger flowers like this. I hope you understand what I'm trying to do here. You can do this by yourself also. You're pretty much aware now what is going to happen. Okay, this is the multiparous cyme. This is the oldest flower, one. Okay, oldest flower, and second, and second, third, and third, fourth, and fourth. Okay, so this is how it's happening. So this is the example of multiparous cymose. In this type of cymose inflorescence, the main axis terminates in a flower, and produces a number of lateral flowers around. Lateral flowers around it. Oldest flower is it in the center. Oldest flower is at the center. And okay, oldest flower is at the center. This is enough. Example is two plants you have to write: Calotropis and Hamelia. In Hindi, Calotropis is called aak. You must have seen this plant whenever you go to a wilderness area, and there is a plant which has thick leaves, and if you break the branch or you break the leaf, you will see a white colored latex coming out, white colored fluid coming out, and this latex is also poisonous. Your parents must have asked you to stay away from this plant because it's quite poisonous. But if you wash your flowers, wash your hands, is perfectly fine. Okay, so I can bring you these flowers because it is also in the flowering stage. I have seen these flowers at an area nearby, so I'll try to pluck these flowers for you also, and I'll show you this also, and I'll also give you the images in the PowerPoint presentation. So if the flowers I am not able to procure them, at least you can look at the images and confirm that what I am trying to tell you is true. Okay, and it will be also good for your notes. So in fluorescence, I will give you in a form of a separate slideshow, a PowerPoint presentation, and then you can do this all by yourself. So today we have completed inflorescence. Our next class will be based on flower, fruit, seed, and tomorrow most probably we will finish this chapter, and then we will move on to anatomy in the next coming week. Okay. So students, if you have any doubts, you can ask me right now, and then you can move on to the next class. Next class will be shortly afterwards. Okay. Any doubts regarding this? Simos, racimos? Okay. Okay, thank you. I can give you a thumbs up. Yeah. You don't have any doubts? Okay, I saw you. Alright. Okay. Thank you, dear students. I'll see you in the next class tomorrow, and I'll see if I can bring you some flowers, some examples also. Thank you. Have a great day.